All right. So welcome to our October 2020 TBDevOps meetup. And today, my partner in security crime, Shreyas, who I worked with on the last several very special projects, which we will not talk about today, will tell us about what is security assurance and how to be friends with the security team and how to build reliable and secure products the way that you will never end up on the front page of Wall Street Journal or newspapers like that with news that you had a some data breach. All right, Shreyas, microphone is yours. Welcome to
All
the.
right. Thank you. Let me start presenting. Hey. Can you all see my screen?
Can you switch to presenter view, please?
Yep.
Thank you.
Is that better?
Yeah, absolutely.
All right. So welcome everybody. So my name is Shreyas Atrekar. I also go by Sam at Starbucks because they never pronounce or write my name properly. As Dimitri mentioned, I am a senior infrastructure security engineer at Salesforce, and I have been working with Dimitri for some projects over the last like a year or so. So something about me, I am originally from Mumbai, India. I did my bachelor's there, moved to the US in 2013, did my master's from Buffalo, very cold. And I moved to Virginia after that. And I have been in Virginia ever since. I started my career with Cigital, which was like a security consulting company. We did all kinds of security reviews for our clients, right? So talk about like threat modeling, architecture analysis, code reviews, penetration testing, even provided trainings for them and the whole shebang. We later got acquired by Synopsys, which is a semiconductor company, but they were coming into security as well. So I was a part of that for about a year or so. And then I joined Salesforce in April of last year. It's been a huge change for me coming from like a consulting background into a product company and security assurance in a product company. But it's been a good change. We can see a lot of progress happening, in such product companies, whereas before in consulting, like we were in and out, maybe a few weeks to a couple of months, but that's the maximum that we were there at or like on a client side, right? So we never got the feedback as to what's happening after we leave or what happened because of the things that we did in that or for the client. So it's been a huge change, as I said, going to Salesforce where we can see what changes are being made because of like what we are doing whole as a team, as well as like what I do personally as well. Talking about my hobbies, every Indian or almost every Indian loves cricket. It's what we do every day growing up. I still play cricket on the weekends, permitting weather. Before COVID, with all of my friends here in Virginia. I love hiking. So that's one of the pictures that we took. So that's the border of, like, you can see 3 states there. It's Virginia, West Virginia, and Maryland in a single photo. So that was cool. We do a lot of hikes in the whole DMV area. And I have recently started biking as well. Again, because of COVID, can't do anything else. So biking it is. So I've been biking for about a month or so, and liking it so far, at least. Okay, so coming back to why we are here for, like, so security assurance. Before we dive more deep into what security assurance is, I want to tell you one thing, right? So I am mostly going to talk about what we call software security assurance. Security assurance is a big umbrella. It covers like your infrastructure, your environment, your software, and whatnot. What I'm going to focus more is software security assurance. Now, what exactly is security assurance, right? Most of us work for product companies who sell something to our clients. How will our clients know that, hey, whatever I am using from this XYZ company is secure or not? Is my data going to be secure? Will I be hacked? As Dimitri mentioned, will I or my data end up on the first page of some journal saying that it was breached or hacked or any of that sort? How do we get um, assurance that whatever software we are using from a third party is secure or not, right? That assurance is given provided by a security assurance, right? So you have a score generally, and that will tell your clients how secure a software is. Now going back, right? So it's a process, right? You have to have a process of how your services are going to function, how they're going to be secured, how they're going to be protecting the data it is carrying, right? And how do you do that? So there are multiple stages of how or what comprises of security assurance. You can chop it as how much, like however you want, right? You can chop it on the basis of like how I did here with HDL process. We can also chop it on the basis of your particular BUs in your company. So every BU will have its own function of how they do security assurance. You can chop it in terms of applications and penetration testing and code reviews, all of those things as well. So there are various ways of how you can achieve security assurance. This is going to be just one of those ways. And before I go any further, if you have any questions, completely feel free to stop me and ask them. My presentation is not going to go for an hour and a half. So please, if you have any questions, just let me know and we can discuss that as well. Right. So I think that's about it for this slide, right? So one of the things that I mentioned was coming up with a score. Now, how will you get that score? How can that score be something that is trusted, if not universally, on a large enough scale that you don't have to explain every time what it is, right? That's where common criteria comes in. And this is just one of the frameworks which we use to specify what our security requirements are. And then on the basis of that, we can judge our security, software security and other securities as well. As I said, software security assurance covers a lot more than software. So it also covers your infrastructure, your environment, so on and so forth. So you can have a common criteria for most of these things. So again, this is one of the examples what we use and what in general I have seen when I was working with Digital. A lot of our clients use that. So you come up with the criteria, right? You come up with your blueprints or requirements of what you as a company want from your security, want your security posture to be. You have those requirements in a central location, hopefully when everybody can see it and see what it means to be secure. So that's what common criteria can give to you, right? And then you compare your services against these requirements, and then you come up with, okay, this service within my organization is secure, this is not secure, and then why is it not secure, and then how can we secure it? All of these things, all of your requirements, criteria can come from common criteria. Common criteria, I mean, it says common, but it's not very, very common. But still, it is usually followed. I think even NIST follows some part of common criteria or uses some part of common criteria for its standards as well. So yeah, that's one of the things. Other things that companies specifically use is compliance requirements, right? So what you have in your what data flows through your systems will also govern what compliance levels you need to have. And it might be any kind of compliance that you require, right? So if you have like government data, for example, your compliance requirements are way, way higher than if you don't have government requirements or government data. Similarly, if you have credit card information, you have to have that compliance as well. I always keep on forgetting the compliance names, but you might know that already. So those will give you what your requirements are. And then security assurance will basically check your software against those requirements and then come up with either a score for your service or just a list of things that are wrong with the service and then how you can make it better. All right, so this is my naive understanding of like what this SSDL process is and how or where we need to put security in. Um, and you might have heard the term shift left. So we always try to catch bugs as soon as possible in the SSDL process, but that's not always possible. So we have security hooks or measures everywhere along the process. So first and foremost is the training, right? You need to train your employees, and these are not security folks. These are your developers, your even your DevOps folks, your response people, your project managers. All of these employees need to know what the security best practices are. As I mentioned, we have common controls, we have the requirements, but if the people who actually make or write the code or make your application don't know what these requirements are, it doesn't really matter how good those requirements are because nobody's going to follow them. So training is very, very important. It's kind of neglected in a lot of companies, which at least from my personal opinion, but it's a very important step in your whole security assurance and security of your organization. So as I said, right, so it involves training and education of all of your employees, not just security folks. You need to update those trainings because we all know how quickly landscapes change when it comes to software and security both. So you need to have these trainings updated because or else they'll go obsolete, right? So it's very important to have a team which is constantly updating these trainings to be kept up to date so that whatever you are telling your employees is actually right or secure. And in the last points, I'm like, okay, effective training will also complement what you have in a security assurance team. So you have policies, you have SDA practices, you have standards, requirements, you do your testing, you validate your testing, all of those things. Training is always going to complement that. So it's not either or, it has to be both, right? I have also seen trainings for like clients. So not just training for employees, but trainings to your clients as well. Because not everything from a security perspective lies on the provider. Some things lies on the user as well. So it would be great as a further development to have these trainings, not only for your employees, but for your clients as well. That, hey, this is what we have in our system. This is how you can secure it, but this is how you have to use it. So I have seen a lot of very, very secure systems being used by users who were not at all like security minded, and that just basically breaks down a lot of things, right? So that training for your clients is almost as important as training for your employees. So going forward in our SSDL process, right? So we come to the design phase. That's where we, as like in any company, you have a design ready for what you have to make or what you have to develop, what you're going to showcase to the client, and what's going to be exposed. This is the first step, really, in having something ready as an application, right? So you have your architecture diagrams, you have all of your DFDs, hopefully like data flow diagrams, how data will flow within the system, across the systems, and between the systems that you have, or any of those things, right? We live in a world which is very much connected right now. So you have integrations with everybody. Any kind of like app that we use has so many integrations right now, be it like Amazon or like Alexa or Google Assistants or whatnot, right? So you have all of this interconnectivity. So you have to design all of those things and keep in mind how you're going to make that design secure. So that's your first stage, which is your design stage. Now, what do we do from a security assurance perspective in design stage? I think the last meetup that you had focused on threat models. That's one of the very basic things and one of the most in-depth things that you do during design phase. Threat models, design reviews, architecture reviews, architecture analysis has a lot of names. All of them can be put into a single bucket, but those are all a little different things, right? So, for example, now a small design review, right? If you use t-shirt sizes, it can be a small design review, or you can have a full-blown threat model, which can be an Excel or an XSL design review as well. I have done design reviews in a day. I have done threat models for a month. That's how varied it can be. There are some threat models which can go more than a month as well if the system that you are reviewing is huge. So threat models generally tend to be more in depth and more comprehensive and take a lot more time than a small design review usually. And then there are various things what you do in them, right? So to give you like a very quick recap of how we do threat models or how we do design reviews. We generally have meetings with the teams, developers, your product manager, your QA person, your testing person, I don't know, if it's a small company, your CEO, I don't know. It depends on like what product you are reviewing, what's the scale of that service, how big is the company, what are they interested in as well. So you gather and make a list of, you create a panel of people who you are going to interview. And you basically start asking them questions, right? The way we do generally do design reviews is that we ask the same question to multiple people. And you would be surprised by how many times we come across like different answers being given to the same question by different people on the same project, right? So you'll hear an answer from the project manager saying, okay, yeah, this is all being done. We are all secure. We're the best service in the world. But when you go and talk to the developers, they're like, yeah, we never did that because we either didn't have time or that was not a priority for us. We had to ship out the software, so security took the backseat, so we never did that. Or even the developers say that we have put in that requirement or put in that control, but the testing team will come and tell, hey, this is that control doesn't even work, right? So it is important to have that cross verification thing wherein you ask the same questions to different people and get that idea and have them come on the same page as to what the answer is for that question. And so once you have those interviews, you make what we call a DFD if they don't have one. Most of our teams don't have one, so we create a DFD for them. DFD stands for data flow diagrams. So it basically is an updated version of your architecture diagram. It will just show data flowing from like one system to other, what data is flowing. Sometimes you can also include like, okay, if it is encrypted or not, and other things as well. So that's our DFD, right? That's the first step, what you do when you do a threat model. Then the next step is going from your DFD to the threat model diagram, which will include like your threat actors, your assets, your controls, the zones in which your software or system is lying. Again, in today's world, not like most of our systems are not going to lie in a single trust boundary. Some of the software is, say, in our Amazon account, like our company's Amazon account, which might make connections to your traditional first-party data centers. It might have outbound connections to some third-party services which you have no idea about. It's also exposed to the internet for your users and things like that, right? So you have multiple trust boundaries, which you mark in your threat model diagram. once you have that, you have a very holistic view of what the problems are, right? So if you have an asset which doesn't have a corresponding good enough control, that's a problem there. So you figure that out, you make that recommendation to the team that, hey, this is where you're lacking, go and do these things, XYZ, right? That's how we do threat models on a very high level. What's the use of doing threat models, right? As I said, shift left is the golden principle in security. So as left as you go, it's better for the teams because it is much less costly to fix those bugs. If you catch a bug in design fix, it is easier to fix it because you just have to make a design change and not have to rebuild your entire system. But if you catch the same bug once you are live, you have to basically shut down your service depending on how critical it is, get a design done, get the code in, have all of your tests for the code, and then deploy it, right? So it's a much more complicated and costly process to catch all of these bugs later. So the earlier you catch the bugs, better it is for your teams. And then you can use any kind of like ticketing softwares to assign work to teams and tag it as like security assurance work, because then you can have a nice report of what you did, what's wrong with the teams or the services that they're building, and how you can mitigate those problems, right? It is important to not just find bugs, and this is going to be the same logic for anything that I'm talking about. Yes, it is important to find bugs, but it is even more important to give proper remediations. When I was like working for Synopsys Digital, even Salesforce, like if you just tell teams that something is wrong with the product, they're not going to listen to you. But if you tell them that, hey, this is what's wrong and this is how you can fix it, and you provide them with a good remediation techniques or good remediation ideas, at least, they are much more, they listen to you a lot more. And because at the end of the day, nobody wants their system to be insecure by default. So they're okay with the work as long as they know what they're doing. So remediation is more important, in my opinion, than just finding bugs. So in your tickets, like whatever you assign to the teams, be sure that you have proper remediations, or that will not work. The link here is a very good overview of how you can do an architecture review for a cloud native environment. You can read that if you want to know more about it.
Sure.
Yep.
Can you for a second on the design? So I can imagine how to do design review for like well-established products where team is there, design is, architecture is pretty clear, they develop a bit of new functionality, they fix bugs, but like they know what they have and they know what they're going to build for the next half a year or so. How this will work for a new project where team is trying to bring as many features as they can, and practically they have no design at all, or they think just one step ahead, and everything else is agile and driven by customers?
Yep, that's a good question. So even if it is like a very new design, right? Even if it's like say brand new, you can always have a design review or a threat model done on that, even if it doesn't have all of the like functionalities that you want. The reason why that should still be happening is that whenever you talk with like specifically teams from security, you get to know a few things which should have been incorporated in your software or system from the get-go, but it was not. And that allows you to make a few changes to your base software as well. You will always have additions on top of it, which should be like reviewed again. And I will come to this later as well, but like design reviews or like anything in security assurance is not a one-time thing. It's a process, right? So it continuously, it is going to go on continuously. So it's not like you have done a threat model once and you're done. Whenever you have any kind of new changes, whenever you have new additions or new as you said, right? So it's driven by clients. So if they want a new feature in your application, and if you're going to build it, it's always good to have that feedback loop with security assurance that, hey, this is what we are building on top of this. Can you help us out with that as well? So yes, it is both for new services as well as like when you're building on top of something.
Got it. Thank you.
So this Yuri, I have also a question. I mean, which documentation you use for design review? I mean, what do you typically get from development team?
That's a good question as well. It depends a lot on how mature that that team or that company or that product is. We have had clients who were so ready that they had the DFDs and sometimes even threat model diagrams ready. It was not complete, but it was there. And then we have had teams or clients which had nothing, not even an architecture diagram. So we had to sit with them and draw that architecture diagram by ourselves. So it depends, but at the minimum, what I would expect is for you to have an architecture diagram, a document describing how it works, and a document describing how your clients are supposed to use it. That's the minimum thing that I would expect from any kind of service that comes for a design review. Everything else we can build on top of that. But at least like these base set of documents gives you a very good idea of like what the system is doing and what the potential deal breakers or potential problems might be.
Okay.
One thing to add here as well, a lot of documentation that we get don't really focus on like the security perspective of it, right? So if you get a document from a product team, it's mostly about how it works and how it integrates with other systems and things like that. It will not generally talk about like inter-service authentication or logging and monitoring, how you're going to do patching, how you're going to do change management, all of those things. So that's a stretch. We very rarely get those documents, but even if you get documents saying this is how my application works, that's a good starting point as well.
Thank you.
So yeah, one thing that you can also do to make this process faster, right? You can come up with like say a readiness criteria or something of that sort. That hey, if you want to come to security assurance or security in general to get your design review done, these are the 5 questions which I need to answer, right? So do you have an architecture diagram? Do you know how your auth and auth is going to work? Do you know what you're logging? Do you know how your patching is done? Do you know how your what's it called? Secrets management is done, these things. So you get a base idea of what that system or software is doing. So that is very, very helpful. And that has like expedited a lot of our reviews as well when I was working for Synopsys Digital and here as well.
Does it mean that you use some kind of standard checklist of questions to ask, or it's really dynamic based on the environment you are in?
It is both. So on the basis of your environment, a question can change, right? So if you're, say, for example, you answer or you say that, okay, my system is completely on Amazon. So your questions will change to reflect those that environment. So you, instead of asking how you're going to do auth and auth, you just ask that, hey, are you going to use IAM roles, for example? Are you going to use cross-account access? How are you going to use that? So those questions will change depending on like what environment you are in. But that's again maturity, right? So at the very beginning, just start with a static requirement document, and then you can go on building on top of that. So it changes as per your environment. It changes as per your even a risk level, right? So as Dimitri mentioned, something that is a net new service versus something that you have already reviewed, but you just have to review like one small component of that, it's not the same thing. So your questions can change on the basis of that as well. So it's a maturity plan which you would have to follow, but starting with a static document is a good enough position to be.
Okay, thank you.
All right. So after design is a build phase, right? So what do we do after we do designs? We have your design verified. We know that, okay, design wise, there's not much wrong in your system. You're good to go, right? That does not mean that whenever you build a system or you deploy it, nothing is going to go wrong, because design is one thing. How you do design is a completely different thing. Just to give you an example, like, okay, when you do design reviews, you can say, okay, my service is going to use JWT for authentication or authorization. Great, that's fine. But how do you use JWT is also a problem, or it can be a problem depending on how you use it. Or OAuth or any of these standards, even though you're using it, that's great. But how you use it is also an issue for security folks. Right. So once you do the design reviews, next comes the build phase. So you build your application, you have your source code ready, it passes all of your unit test, great. What do you do after that? So there are a couple of things in this section. One is the source code review, right? Source code reviews, as it says, is reviewing your source code. I have done source code reviews, but not as much as I've done anything else. So I can tell you a little bit about source code reviews as well, but I might not know a lot more. So source code reviews, as the name suggests, it can, or as I have written in the site, it can be automated or it can be manual. There are many tools available for doing source code reviews. Checkmarks, Spotify, and Coverity are, at least last time I checked, the top three tools in that domain. Now, a very fundamental problem with any of the automated tools for source code reviews is that there is not even a single one which will work for all languages, right? So every tool will have its own strengths and weaknesses. So some tool might be great at Java, but it would be very, very bad at C or Go or any other things, and vice versa as well. So it's very difficult to have one tool. If your company uses multiple programming languages, it's difficult to have one tool to scan them all. And these are costly tools, so you mostly would not have more than one running an enterprise version in a company. So depending on like what your needs are, what's the most widely used programming language in your company, you can either go with one of these automated tools or you can do it manually. And you can imagine how much time a manual source code review might take. So generally, when we do manual source code reviews, it's not going to look at each and every source code line of your software or system. It's going to be what I'm going to talk about next, right? But when it is an automated source code review, fine. You can do it. Can scan the entire repository, whatever you have. It can be like hundreds of thousands of lines of code, and it will go through that. Second problem with automated source code reviews is that it'll give you a lot of false positives, like a lot. And again, this will differ on the types of tool that you're using and what you are, like what programming language you're using. The false positive rate is also going to change on the basis of that. That's why a manual security source code review is better in that sense, because even if you get like 5 things or 10 things, you are very, very sure that that's a problem, which might not be the case with any of these tools. Like I have had tools give me like thousands of bugs, but not even one of them were actual bugs, because it was not able to like correctly correlate what was the source, what was the sink. That's jargon for source code review. So it basically sees from where, if you have one workflow, from where it is beginning to where it is ending. I think that's source and sink. So if it is not able to get that proper correlation, it flags it sometimes, and that's almost always a false positive. So we live in the CI/CD world right now again. So every commit that we have should be reviewed. You should have unit tests written to ensure the code works. And unit tests are not really security tests, but they're more of like functionality tests to see if whatever I want my code to do or what I want my system to do, it's doing that or not. But it has to be reviewed as well. It is much easier to do automated reviews for like commits because those are very, very small changes, right? So that is one area where I think automated source code reviews might be much better because then you can integrate that in your CI/CD pipeline, and then they can just run every time you have your commit or every time the pipeline runs. And then you can tweak your what you say tool to remember what the false positives were and then not report them the next time. So it gets better over time. So an alternative to to source code reviews is inspections and walkthrough. As I said, this is mostly manual, done with a group of people. So you can have people from your development team, from your security teams, from your DevOps teams, from your QA teams, testing teams, all of them sit together and go through your source code line by line. But what you see is like major functionalities or major workflows, right? So if you have an authentication workflow, you sit together with your, auth and auth guy or IAM guy or whatever, and then you walk through that entire workflow for auth and auth line by line. And it can be like hopping and skipping from one page to another, and that's how you follow that. So instead of like, going file by file, you go through you walk through a particular functionality or a particular enhancement or something of that sort. So that's the difference between like source code reviews and inspections. But mostly like where I separated is mostly source code reviews are done automated in an automated fashion, and inspections and walkthrough is mostly manual, wherein you have a group of folks who know what the service is doing and who know what to look into it. They sit together and do that review. Any questions? All right. So next phase is release, right? So once you have done design reviews, you have done source code reviews, everything is great. You now release your application. Hopefully not in production directly, but somewhere which mimics production or even in a dev environment. So what do you do after you release? So again, there are two things here. You have dashed and you have pen testing. Similar to what we talked about in build, this also can be separated into manual versus automated. So DAST stands for Dynamic Application Security Testing, which is mostly a black box test, right? And you also get tools to do this, and which you can automate. So there are tools who I have mostly used AppScan and sometimes Burp for this, but there are other tools as well. I'm sure that do an equally good job. So it's a complete black box testing, right? Testing. So if you're not aware of what black box testing is, it's where you have no idea of how the system works internally, right? So you don't have access to like source code, documentation, any of that sort. You just provide credentials to your tool, and then it just runs off and goes through every link that is there in your application, types a bunch of random things in all of your text boxes, tries to hit enter, tries to perform XSS on anything and everything that it can find, and it does a whole lot of things in a very short amount of time. It also does things like denial of service and other bad things, which we generally turn off because we don't want our clients facing downtime because of these tests. But that's what DASH stands for. So it's a complete black box testing wherein you just provide credentials. to either a tool or even a person, and then they go off and do their tests. This can also be done by security professionals, like manually, but that mostly falls under the purview of penetration testing. One thing which I really think is works is that if you are like, there are some companies who have all of these teams internally, right? So you have your pen testing team, you have your architecture review team, everything inside in-house. But there are a lot of companies who don't have that much amount of manpower or expertise to have all of these security folks within the company, so they outsource it to different companies like Digital or Synopsys. It is very important to have penetration tests done with not a huge company which does these things for like compliance purposes, but have like it is much better to have like a small team of like a company which has like 5 or 6 people, maybe, just throwing out examples, who are very, very specifically pen testers, right? To do your penetration testing, because they can find things which a lot of people cannot. They have been doing pen testing like day in day out for like years, and they are very, very good at breaking into everything. So that's just a side note that if you don't have all security personals or professionals in house, and if you're going outside to have have your pen testing done, go to somebody whose main thing is pen testing and not like everything. So how is a pen test different than DAST? As I said, it is mostly done by like manual people, and they can see how your application behaves in certain conditions, and then try to figure out how they can attack it. If this is something that is done internally or in-house, your pen testing team might also have access to your source code and documentation. Right? It basically gives them more idea about your application, and then they can have more information about how they can penetrate that, or how they can basically hack it. So that will differ on like depending on who is doing a pen testing. If it's outside, mostly people don't want to provide the source code, or companies. But if it's internally, then sure, you can give the source code to your team, and they can perform their penetration testing. I have seen a lot of clients use penetration testing to also confirm the results of a design review. So in design review, if somebody says, okay, we are implementing auth and auth Z using XYZ, pen testing is a time when you can actually see if it is accurate or not, or if it is done properly or not. If you have filed bugs or work items on your team, when you do design reviews or source code reviews, this is also a time to see if they have fixed it or not. So in an ideal world, you should not find a lot of things during penetration testing, but that almost never happens. So you always find something. And as I said, we are shifting for the right now. So bugs will be more difficult to fix here, more costlier to fix, and it requires downtime in the case where if your app is already in production, and if it's a serious enough security flow to have that down for some time. So yeah, as I said, try not to have bugs here, but that all like never happens. So you'll always have bugs, because not all kinds of like flaws and bugs can be found out in the design review phase or the source code or the build phase, or the build phase or design phase. So they will be found in the release phase, and it's just the way it is. Yeah, I think that's about it for release. Any questions?
So you said that pen testing is like usually external activity. What about kind of testing for regular confirmation that system is secure? Like, does it make sense to write some automated tests for security?
Yeah, so that can be done using Dash, or you can have some kind of automated testing, kind of like canary tests or unit tests as well in your CI/CD pipeline. Penetration testing is not generally done for um, small changes, right? Pen testing is mostly done on an entire service because um, um, an attacker will never just use your one change to compromise a system. If something else is broken, he can definitely use that to gain access to the new part that you have developed. So pen testing is mostly done on an entire system and not just like small components. So you can have canary tests and unit tests for those things in-house or internally. But when we talk about generally pen testing or even Dash, it's done on the entire system and not just scoped to a small um, enhancement or a small feature that you have built recently.
I see. Okay, thank you.
Cool. So post-release, right? This is where this is what I talked about earlier as well. Feedback loop is very important. It is never the case that you do a design review or penetration testing or source code review just once and you can just sleep happily knowing that all of your software is safe and secure. That's not how it works. The feedback loop is important. So whenever you have changes done to your software, get it reviewed again. Even if you don't have changes done to your software, have a periodic review done of your most vulnerable, not vulnerable, but most critical services, because things change a lot in that period as well. So you might be using a lot of like 3PP libraries or off-the-shelf products, right? It is possible that in the last year or so, they have some new security flaws in them that were discovered, and then that in turn now affects your application as well. So it is important to have all of these services be reviewed periodically. And this has happened a lot as well. Like when I was working for Synopsys, we did a lot of these reviews on a yearly or a 2-yearly basis. And we found out a lot of things which were not present in the first time when we did the review, but now they are a problem now because of what happened in the backend. So this is very important. It does help, and it does give you a lot of good findings as well when you do it the second time too. So don't ever think that it's just a one-off thing which you have to do and then be happy about it. Feedback is not just about having these reviews done periodically, but it also includes feedback from other teams in your company, right? So you will have threat intel team, you have incident response, offensive security, which is, you can also call it as red team, and your engineering teams as well. It is important to get all of the feedbacks from these teams because they, like incident response and threat intels, are your frontliners, right? If any of your systems get breached or hacked or compromised, they're the first ones who know about that. So it's important to get feedback from them as well to learn more about what's going wrong, like where are these security issues coming up from. We did all of these things, so why are we still being compromised? It's important to get all of this information back from threat intel and incident response to make changes to your process if required, or to, just for education of the software security assurance folks as well. So yeah, as I said, it enables the security assurance team to make changes to their methods, their processes. A lot of times what we have observed is that a lot of breaches happen because of how people use software. and not just our clients, like even within a company. So a lot of those are like user errors. So how can we fix those? We need to have proper processes or methods to to further educate and train our employees to use that securely, right? So it's a continuous process. And yeah, as I mentioned, it's a continuous process. So you need to perform reviews periodically, even if you have not changed anything in your system or application. You still need to have it reviewed to protect against current threat scenarios. So other than the whole SSDL process, you have automation and guardrails. You always need to automate as much as the process as you can, because that's how you will scale. If you are currently doing like 10 design reviews and your company is growing so fast that it has 100 new designs every week or every month, your backlog is going to blow out. So you need to have automation for a lot of these things, and that's something that you should always strive for. The automation team has to work with a lot of other teams to just understand what their needs are and what can be automated, how we can automate it, and how much time is it going to save for everybody. So automation is very, very important. The more you automate, the faster you'll be able to improve your coverage and also provide like greater depth to your reviews. Guardrails are equally important. Now, what's guardrails? If we talk about Amazon, right, as an example, we have what we call service control policy. So it basically is a policy which says that nobody can do XYZ. So if I say that, okay, nobody can create a security group which has access open to the world, and if somebody does that, they're not going to be allowed to do it automatically. And that's a guardrail, right? So you are stopping the developers from doing stupid things in the first place. The more guardrails you have, again, the faster your security process is going to be, because you don't have to check for those things. Guardrails are very important. So you have security control policies. I have seen OPA used a lot. That's Open Policy Agent. You can define your rules there, and then OPA basically converts those into some kind of a score. And then you can have gates saying that, okay, if the score is more than a particular threshold, then push it back. If it's not, then allow it, things like that. So guardrails are important as well. If you have these guardrails, you also there are always ways to circumvent the guardrails as well. Well, not always, but most of the times you have ways to circumvent the guardrails. So what also helps is that once you know that you have guardrails in place and somebody circumvented that, and you have detections around it, you are very, very sure that was a malicious attempt, right? So if you have a guardrail in place, but somebody took extra steps to do that thing, and you detect that, that's almost always certainly a malicious attack. So you should also, well, that comes to a different point, but you should also have detections for most of these things, because again, no matter how good your security assurance process is, some things are going to slip through the cracks, and some things are going to happen which might or might not be security incidents. So you need to have detections for those things, which is a completely different topic, which we can cover sometime later. So what are the challenges, right? The biggest challenge is scaling. As I said, your team is not going to grow at the similar pace as what your company is growing usually. So if you can do 10 design reviews, as I mentioned before, and the company is growing so fast that your backlog is just going to blow up. So how can you scale effectively is always a challenge. And throwing more heads at it will never solve it, because it's a never-ending thing. So you have to have other things like automations and guardrails and quick review strategies, things like that, to bring down that queue. coverage is another thing as well. So not everything is reviewed by security. It's kind of an honor system in most of the places, wherein you as a service team need to open some kind of a ticket or some kind of a review to have that. If your CI/CD pipeline has some of the security inbuilt in it, then fine, all of your commits go through that. But that's not the case almost all the time. So how do you improve your coverage? That's also a challenge that I have seen a lot of companies face. Quality of service as well. If you have 10 people working on, like each person working on 10 different threat models at a time, it's not going to be a good quality threat model, because it's almost impossible to context switch that much when you do a threat model. You have to be like focused on one system to think about all of the ways how an attacker can compromise that system. So if you have a lot of things, the quality is going to go down. And the last thing is consistency. Everybody is different. 10 different engineers on a security assurance team will do a threat model or a source code review or pen testing differently. So you will not have consistency, like complete consistency in your reviews, but you have ways around that, right? So you can have like a checklist of, okay, these are things that we have to check, period, right? So you have to do all of these things. If you have time, if you have energy, if you want to go above and beyond to do that, or to do anything above, like other than that, sure, you can do that. But this is the minimum set of things that you have to do. And that's what I have seen used in most of the companies that I reviewed. They have a min list of requirements, or we had a min list of requirements that we used to check for. And then if you want to do anything more, sure, you can do that.
Can we return for a second to challenges? I'm thinking about the opposite way of the opposite direction of scaling. So let's say we are a startup with 3 engineers in total, but we still want to do some security assurance practices. So how can we scale down the process to the level that not even full-time engineer can, or somehow collectively the team can keep the system, monitor it, automate it, stuff like that?
So there are multiple ways of doing that. If you are a very, very small team and you want to do some kind of security assurance on a product, unless you have somebody who is like trained in security, it's very difficult to do it manually. So you'll have to rely on tools. And there are free tools as well. Like if you, again, as a startup, if you don't want to spend a lot of money, there are free tools which help you do a lot of these things. They're not very good tools, and it's obvious because they're free, and tools are never going to, like, unless you have a very specific tool that you build for your own company, they're not going to do very well. But if you want like a minimum assurance, okay, I have done something, right? You can always use these free open source tools for all of these things, and have that one particular engineer who might not be a security person just triage the results of those tools. So Burp, I know that Burp also has an integrated dashed scanning. AppScan maybe has a free version as well. There are various source code tools which offer like a free basic version. So you can use that and then have somebody triage those results. But that's not going to be like a very good. It's not going to give you good coverage. It's not going to give you good fidelity of that information as well. So it's going to give you a lot of false positives, and you're going to like scratch your head figuring out what are the false positives and what are the true positives. But that's the one thing which I can think of if you don't have somebody who is a security professional.
So from what you say, it's probably easier to outsource that.
That's what I would, yeah, that's what I would say. If you have, and these are generally not super expensive tests if you outsource them. I mean, it depends on where you do it and how big that engagement is going to be. But you can have those basic set, like basic tests done in not for a lot of dollars. So it's easier to do that because it also helps you with compliance if you need that. So that's an extra bonus that you get.
I see. Thanks.
I cannot see the Google Meet thing because of the presentation. Was there a question in chat?
Yeah, the question was if anybody used check marks.
I did use it in my previous job, but I have no reviews about that. I used it when we were digital, but when we were bought by Synopsys, I think Coverity is Synopsys' tool or one of the Synopsys company's tools that does source code reviews. So we generally relied on Coverity after that, but I did use check marks. I don't remember a lot about it. If anybody else has. Take that as a no. But yeah, Coverity, I did work with Coverity a lot, not a lot, but for a small time when I was at Synopsys, and it's a very good tool. I think for Java or C, it is one of the best source code review tools out there. So I would definitely, recommend checking that out. But again, that does not do a good job at all of the languages. Like Go, at least when I was at Synopsys, it might have changed now, but it was pretty good for either Java or C, one of those languages. So what's the takeaways, right? There's no right or wrong ways to do security assurance. I just said this is just one of the ways how you can do it. There are multiple other ways how you can split your security assurance teams and do all of these things. Just make sure to cover all bases. So, design phase, your build, your implementation, your feedback, training, everything. It's important to cover everything and not leave anything behind, because there are some bugs which you can only find in design. There are some bugs which you can only find in pen testing. There are some bugs you can only find in source code reviews. So there's not one thing that you can do which will find everything that's wrong in your application. So it's important to do everything all together as a package. Collaboration is very important again. I have seen a lot of time wherein things just went bad because of lack of collaboration. So collaboration between your security assurance, threat intel, detection and response, engineering teams, everything has to be tight so that you have a better security assurance process. Training is important. We spoke about that. Last but not the least, remember that you cannot fix everything, right? No matter how much time and money you put into all of these things, some things will slip through the crack, and there are attackers out there who have a lot of backing and financial support and whatnot. So it's, I won't say impossible to fix everything, but it's very, very difficult that you are going to fix each and every hole in your system, but just try to be as good as you can, do your best, and that's all we can hope for. That's about it. Any questions, comments, concerns, feedback?
Yeah, this is Yuri, another Yuri. You did not mention anything about like third parties. For example, you use third parties and there is some vulnerabilities. And how are you going to check if it is a vulnerabilities? Because you're supposed to monitor your security and things happen over the time. Can you please tell a little bit more about this?
Yes, so that's a good point. I think I forgot. So 3PP security is important. We have had our clients have a process where they reviewed all the 3PP that you are using in your system. And that's a different process as well. So 3PP, it's another software in itself, right? So you can put it through some tools to see if you get back some vulnerabilities in that. So 3PP is always going to be something that can be a bit of a problem because 3PP is, the vulnerabilities depend on what version you're using. Plus, it also depends on what packages you're using from that 3PP or what like functionality you're using from the 3PP. So you have to take into consideration all of those things. But yes, it is important. It is done in security assurance as well, wherein you have to go through the 3PP and see what your system is going to use, and just check for like vulnerabilities. There are many websites out there which you can just put what the 3PP is and along with the version, and it throws out a bunch of like CVSS vulnerabilities that were found on it. So at least you have a basic idea of what is wrong with that particular 3PP.
And 3PP is third-party product.
Right. Sorry. Yep. So 3PP is third-party product. So you can have those. You can have that in your pipeline as well, wherein you can see what 3PPs you are using and just scan them and just see if you have a particular CVSS score, say above 8 or 9, and then you're still using that functionality, then that's a problem, and you should have other ways around it.
And one of the good practice around third-party products, and especially libraries, is to sort them from the local repos. So developers, if they want to bring a new library, they go through, again, security review process, then bring that library into local repo, and then source it from there instead of bringing from internet some random source code.
Yep. Yeah, that's important as well, but it's equally important to also keep like you should have a period as like when that 3PP is allowed to be used, even once it is inside your system. Because I said if it goes old and if it has new CVSS scores, then you don't want that to be deployed. So you always want the latest version of that particular 3PP to be used in a system. Any other questions? If not, I'll hand it back to Dimitri. Thank you all.
Yeah, thank you, Shreyas. So